Welcome to The Explainer. Today, we're diving into one of the most powerful and honestly most fascinating natural forces on our entire planet. We're going to decode a massive global climate pendulum, one that swings back and forth across the Pacific Ocean, literally dictating weather patterns for the whole globe. But before we get into the mechanics, just think about this for a second. How exactly does a warming patch of ocean in the middle of the Pacific cause a devastating drought thousands of miles away in India? Sounds impossible, right? Well, as you'll see, our global weather systems are deeply, beautifully, and sometimes tragically interconnected. A tiny temperature shift in one ocean can send ripples across entire continents. Okay, let's dive right into this. Here's our roadmap for exactly how this happens. First, decoding the ENSO cycle. 2, El Niño, the warm phase. 3, La Niña, the cool phase. 4, global climate disruptions. And 5, India's monsoons and winters. So, part 1, decoding the ENSO cycle. To really grasp the extremes here, we first need to understand the baseline of our climate pendulum. The whole system is formally called the Niño Southern Oscillation, or ENSO for short. Basically, it's this continuous cycle of fluctuating temperatures between the ocean and the atmosphere, specifically out in the east-central equatorial Pacific. It's kind of like a giant climate seesaw. And what's wild about this, it's not a predictable, regular cycle like our normal seasons. The pendulum swings at totally irregular intervals. We're talking every 2 to 7 years, with episodes usually lasting about 9 to 12 months, though, some prolonged events can hang around for years. Now, when the seesaw is perfectly balanced, we get neutral, non-El Niño conditions. Normally, you've got these really strong trade winds blowing west across the tropical Pacific, and they're pushing warm surface water over toward Asia and Australia. Now, because all that warm water is getting shoved west, cooler water literally has to rise up along the coasts of Ecuador, Peru, and Chile just to replace it. We call this upwelling. It pulls up cold, incredibly nutrient-rich water to the surface, which is absolutely crucial for supporting massive amounts of marine life. So that's our baseline. That's the normal state of affairs. Which brings us to part 2, El Niño, the warm phase. So what actually happens when those dependable trade winds fail? Well, we get El Niño. It's traditionally known as the little boy because Spanish-speaking Peruvian fishermen first noticed these unusually warm waters popping up right around Christmas. In this phase, notice how the trade winds have just totally weakened or faltered. And because those winds aren't pushing west anymore, all that warm surface water just sloshes right back east towards South America. As a direct result, that cold upwelling we talked about completely suppressed. The nutrient-rich cold water just gets trapped underneath a thick blanket of unusually warm surface water, and that entirely changes the air pressure above it, literally shifting the entire atmosphere. And hey, when we say warm, we are not talking about a pleasant day at the beach. Scientists track this heat using the Oceanic Nino Index, pulling data from high-tech buoys deployed all over the ocean. Now, a weak El Niño might only bump temps up by maybe 4 to 5 degrees Fahrenheit, but severe events, they are staggering. Take the intense El Niño of 1982 to 83. Sea surface temperatures in the eastern tropical Pacific spiked a massive 14 to 18 degrees Fahrenheit above normal. That is a colossal injection of raw heat energy straight into our atmosphere. Moving right along to part 3, La Niña, the cool phase. Eventually, that massive heat dissipates, right? And the pendulum swings back. But it doesn't just stop safely in the middle. Often, it violently swings to the exact opposite end of the spectrum. We call this the cold phase, or La Niña, meaning the little girl. Let's actually put these two head-to-head for a second. They are literal opposites. El Niño is the warm phase, driven by weak trade winds, which causes suppressed upwelling. La Niña is the cold phase. It brings intense, strong trade winds, which triggers even stronger cold upwelling. Seeing them contrasted like this really helps click the mechanics into place. So during La Niña, those normal baseline conditions we started with are just pushed into overdrive. The trade winds get supercharged, shoving massive volumes of warm water way out to the west. This sets up lower air pressure and intense, heavy rainfall over in the western Pacific. Meanwhile, that upwelling of cold water along the South American coast becomes incredibly aggressive, which leaves the central and eastern Pacific abnormally cool and dry. Now, the actual threshold for officially declaring a La Niña is highly specific. Scientists are looking for a drop in sea surface temperatures of more than 0.9 degrees Fahrenheit. But it can't just be a quick dip. To officially be La Niña, that temperature drop has to be sustained for at least 5 successive 3-month seasons. Once it hits that specific mark, La Niña is officially on, and it can stick around for anywhere from 1 to 3 years, completely rewriting global weather patterns in the process. All right, part 4, global climate disruptions. Because as we all know, what happens in the Pacific definitely does not stay in the Pacific. These immense temperature and pressure shifts wreak absolute havoc all over the world. Let's rapid fire through the impacts of an El Niño event. As that warm water shifts east, it brings drastic, heavy rainfall to South America, causing severe coastal flooding and erosion. On the flip side, the Western Pacific gets completely starved of moisture, which triggers severe landscape-altering droughts in Indonesia and Australia, really threatening their water supplies and agriculture. There's also a pretty grim public health side to this. The flooding spikes outbreaks of cholera, dengue, and malaria. But strangely enough, there is one weird positive. The wind shear created by El Niño actually reduces the total number of hurricanes in the Atlantic Ocean. Now, let's flip the coin to La Niña. Because that warm water and low pressure get shoved all the way to the west, Australia takes the absolute brunt of the moisture. And we aren't just talking about heavy rain. Strong events cause catastrophic floods. Get this, during the 2010 La Niña, floods in Queensland were so bad they forced over 10,000 people to evacuate and caused over $2 billion in damage. It also dumps heavier rain on southeastern Africa and northern Brazil. Over in Europe, it brings milder winters in the north, but much colder, snowier winters down south near the Mediterranean. And unlike El Nino, La Niña sets up the perfect atmospheric conditions for stronger and much more frequent hurricanes in the Caribbean and central Atlantic. Finally, part 5, India's monsoons and winters. To really grasp the sheer scale of these events, let's bring it all home and zoom in on one highly sensitive region, the Indian subcontinent. The crucial thing to understand here is how this pendulum affects the Indian monsoon, which is literally the lifeblood of the region's entire agriculture and industry. Long story short, El Niño is generally terrible news for India. It starves the moisture, contributing to weaker monsoons, and sometimes triggering devastating droughts. But La Niña feeds the monsoon. During a La Niña year, summer monsoon rainfall tends to be much higher than normal, especially in northwest India and Bangladesh, which obviously brings massive benefits to the whole Indian economy. But it doesn't stop there. La Niña also completely changes their winters, and the mechanics of this are just fascinating. Basically, La Niña influences the subcontinent by setting up this north-south low-pressure system. Think of it like a giant atmospheric pipe. It literally pulls freezing cold air all the way down from Siberia and South China. And because of how it's oriented north to south, that icy blast extends much further south into India than it normally would, plunging temperatures as far south as Tamil Nadu, while somehow largely bypassing the northeast entirely. It is a perfect textbook example of how complex pressure systems act like atmospheric highways. So what does this all mean? Well, it brings us to our final thought. The ENSO Cycle, this dance between El Niño and La Niña, literally dictates the fortunes of farmers in India, the safety of coastal residents in Australia, and the hurricane risks for millions in the Americas. And yet, this massive global engine runs on a totally unpredictable, irregular cycle of 2 to 7 years. With such immense, earth-shaping power wrapped up in so much unpredictability, it really leaves us asking, how will the ever-swinging extremes of this climate pendulum reshape our fragile global future? It's a massive puzzle that researchers are trying to solve every single day, and for sure, something we all need to keep an eye on. Thanks for joining me for this explainer, guys. I really hope this helped you decode the incredible mechanics driving our oceans.